SciByte is produced by JupiterBroadcasting.com, independent entertainment that's on demand. Check us out. Hi, everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast. We recorded this one live on March 20th, 2012. My name is Chris, and joining us, like every single week, is our host, Heather. Hey there, Heather.
Hello there, Chris.
Hey, happy science to you.
Happy science.
Okay, what do we got coming up this week?
Okay, today we're going to take a look at more Legos in space or near space, Venus Transit, a meteorite that crashed through a cabin, guiding lightning with lasers, updates on Encyclopedia Britannica, near-orbit skydiving, check the latest news on neutrinos and solar storms, and as always, take a peek back into history and up in the sky this week.
Love it. Anytime you have an episode titled Meteorites and Lasers, you know you've got my interest.
Yeah.
I want to just take a quick moment and say thank you to everybody who's been writing in, SciByte at JupiterBroadcasting.com, and just leaving comments where you watch this. You guys are awesome. People out there love the show, Heather. I hear from people all the time, and they just totally love the show. So there you go. That's compliments to the host right there. All right. Well, I don't really have anything to chat about at the top of the show. Do you want to jump right into the news?
Let's go.
All right, Heather, what is our top story today?
Today, another Legos in space.
Nice.
Again.
Times 2.
Times 3, or however long this is.
All right, okay.
A couple times now. So, Romanian gentleman launched a Lego space shuttle into the stratosphere on the back of a weather balloon. The video is pretty cool because you can, like, especially the first part of it, up until he gets into near space, he's just going across clouds and stuff.
Yeah.
You can't really see the strings.
Oh, so it looks like it's flying?
Yeah, little yellow space shuttle just kind of flying through the atmosphere.
Yeah,
and once he gets to the top, he's spinning around and the sun is shining on it. It still looks cool, but it's definitely lighting up the wires.
But it made it all the way up, huh? Up through the atmosphere and beyond, or did it just stay? Oh, in the stratosphere. So that means it stayed within. Yeah, okay.
Yeah, it flew to about 114,000 feet or so.
Okay.
So it's another one of those that's sort of quote-unquote near space.
Mm-hmm. I mean, closer than I've been. Well,
yeah, closer than a great deal of us has been.
Yeah.
But this is one where originally it was kind of funny. He was looking for support on a different project. I think sort of, build a rocket in the back of your yard and see, a big rocket and see what could happen. But he ended up finding a businessman on Twitter.
Jeez, really?
Yeah. And discussed it with the guy. Then they decided that they instead launched something on a weather balloon. Huh. And they decided, Lego Space Shuttle.
Well, I got to say, it's good PR. I mean, so if he's trying to launch something, well, people are talking about him now.
Yeah. And so he and his father, he's from Romania, but the flight clearances and the waiting times were pretty stringent.
Are you serious? Wait, for a balloon?
Yeah. Well, we've talked about it here in the States where it's like, or Canada, it's like, what are the rules? And there's not really a lot of rules for weather balloons per se.
Mm.
Some of these bigger, zero pressure balloons, as we might call them, the very big ones, once they get over a specific size or weight of payload, then yes, you have to clear through the local airport and stuff.
I see. So he probably must have had a certain size just to get it up that high.
Just a regular air balloon, like we've seen the Canadian boys launch the little Lego man, or the MIT student launched their acceptance letter. Mm-hmm. So it's just specifically in Romania there were rules about what he could do, and so they're like, Germany's good. His father worked in Germany, so they just kind of drove across the border over to Germany and there.
It's interesting, too, as this thing gets higher and higher. It's frozen over. There's ice. It's just covered in ice now.
You can see a little ice over it. You're like, cool. But it's like, aw, the space shuttle's in space again.
Mm-hmm. Yeah, the chat room said cheapest NASA launch ever.
Yep.
Oh, that's sad. So I guess they must have safely recovered it if they got the footage of it, too, right?
Yeah.
Well, that's good.
So it's another one of those things that as long as you have tracking, good tracking, especially now with phones that have such great GPS.
Yeah.
I mean, tracking units, and you can essentially hook it up to a map and it says, drive down this road. Now take the turn left. Now take a right, and it'll bring you straight to it.
It's interesting just watching this because I don't know. It seems almost childlike in a sense to want to do something like this, but then at the same time, the flip side is it still seems like such a respectable accomplishment.
Yeah.
So I'm sort of of two minds of a story like this because I do kind of giggle at it a little bit. It's like, oh, you put a toy Lego up into space attached to a balloon. That's adorable.
Yeah.
But I want to do it.
Yeah. Well, a lot of these are, you put something into space and you're going to take pictures, you're going to take video, and the payload has to be pretty light.
Yeah, sure.
So, sometimes it's just the video and the camera, and here lately it's been, a small payload, the little Lego man or diploma or, acceptance letter, things like that. So, it's very visual things sometimes can do it. And the lightweight thing that has a very three-dimensional attire is Legos.
Yeah.
They have little Lego space people and Lego space shuttles.
They are sort of like the perfect thing for this in a sense when you think of it like that.
Yeah, because they're lightweight. They make up all sorts of stuff.
Well, that's awesome. That's awesome.
Yep.
I want to do a Jupiter Broadcasting promotion where I send up a shuttle with a Jupiter Broadcasting sticker on it, and maybe if I could somehow figure out a way to live stream it, that'd be better too.
Maybe not live stream it, but I'm pretty sure if you just do it and have something like that, then it could do it. I've actually seen some of these. Maybe just when it actually went up to space, but where they have like a little board and you can buy square inches on it, like of ad space.
Oh yeah.
And like put it up and then post it on YouTube, and it'll get a whole bunch of hits, and it'll be like Joe's Car Shop right there in the right corner. They paid $50 for it to get that little square inch of space for. But I don't know how I read Joe's Auto Shop in 1 square inch.
The Lego company must be just loving the publicity too, right?
Oh yeah,
it's just great publicity.
I mean,
for
they've
free.
got that specific shuttle. They've got other ones. They've got a whole bunch of different space Lego sets.
Well, there you go.
And we were talking about Legos going to near space.
Right.
But we've talked about them so much. I didn't know if people know that Legos themselves have gone to space and even beyond Earth's orbit.
I didn't know that.
Yeah. I kind of find it funny. On the space station, they built a little Lego space station.
On the space station? Oh, the space station itself is kind of like a giant version of Legos in a sense. It's kind of assembled sort of piece by piece. So it kind of fits they play with Legos on there.
Yep. Real space station, 200 astronauts, 12 countries, more than a dozen years. Lego space station, 1 astronaut from Japan, 2 hours.
Well, the scope of the project is a little different.
Yeah. Now, it's one of these that could not bear its weight under gravity. It would just crumple. The weird thing was that there was actually a flammability hazard. So he built it that some of the pieces obviously would have to come up, pre-assembled, all the tiny little one slot pieces, the dot pieces, and he built the rest of it in a glove box. And then he was doing it part of an educational thing. So they took it out of the glove box. He, for the 2 hours that took him to film the educational, beam down, then they put it back in a sealed container and stored it away. They're like, we could only have Legos for 2 hours. Everybody have fun, and then they got to be put away.
Yeah, well, I mean, you never know where one of those pieces might end up if you're not careful. Just to be floating all over the place. You could be, geez. That could be a real mess. I mean, I think I have a mess with kids when they spill stuff on the ground. Yeah.
Well, I mean, there's obviously the little dot Lego piece floats over here and gets in a piece of equipment that it really shouldn't do.
Oh, yeah. Or a piece of food or anything.
Well, yeah.
It could float around, you bite down. Oh, where'd that come from? Oh, sorry. I was playing with Legos 3 hours ago.
Almost as bad as glitter.
Oh, boy. Glitter in space. Now that is a real threat.
Glitter on Earth self-multiplies.
Yeah.
But space.
Oof.
And actually, one of the probes to Jupiter, there's a specially constructed little Lego mini figures of the Roman god of Jupiter, his wife Juno, and Galileo Galilei. And it's the probe Juno, who's going down and it's kind of looking down underneath the cloud cover as much as it can and kind of looking at what's there. And so it was kind of funny because Jupiter, essentially the Zeus of the Greek gods, the equivalent of Zeus to the Greeks. And Juno, the wife, was supposed to peer through the clouds and reveal the true nature. And so the Juno probe is also kind of peering through the clouds.
Aw, isn't that a nice little play on words?
I know. And then Galileo was the first person to point a telescope at it. And, and they were able to spot the 4 largest satellites of Jupiter. So they kind of named that after him too. And so it's actually going to be scheduled to arrive in July of 2016. It's going to orbit Jupiter for about a year, and then they'll crash it into the gas giant planet. The figures themselves were not just regular Legos. They were made of space-grade aluminum.
Space grade?
Yep. So basically the size of normal Lego figures, but the plastic...
I would love to have aluminum space-grade Legos.
Yeah.
They should just sell those to the general public.
I don't know, the price point might not make it.
Oh, do you know what the price was?
No, because they don't really say for that kind of a thing. But
it must have been really expensive, huh?
Yeah, space grade aluminum, slightly more than a Lego set.
I would guess so. Well, they don't have to make it space grade. I would just settle for an aluminum set. That'd be fine.
Yeah, because you know that kids would never whack their sibling with an aluminum.
It's not for the kids, Lego. Heather. It's for me.
Okay. Sure, you kick a Lego away from kids.
I mean,
they're like drawn to it like magnets.
Yeah, that's true. Boy, could you imagine? Yeah, that boy, Dylan. There's no way I could keep him away from that. There's no way. Yeah. Well, this is pretty cool. So in the show notes, you've got links to some info about this guy too. That's sort of the guy behind it. What's his name? I can't remember what his name was. But anyways, it's some interesting stuff. It's just an interesting story in general.
Yeah.
And also a link to them talking about Legos on the International Space Station. So that's in there too. So you guys can check that out. Do you have any other thoughts on that story?
No, it's just more Legos, and we'll see how far all these, launches are getting more popular and bringing in the YouTube videos. So
keep your eye out, folks, for the SciByte launch someday in the future. Oh, well, let's just take a quick moment here to stop for just a brief moment and say if you've enjoyed the programming that Jupiter Broadcasting and specifically the wonderful SciByte brings to you, you might consider when you're about to go shopping, stop by jupiterbroadcasting.com first. Heck, you could even open up a new episode of something in a tab while you shop. If you scroll all the way down to the very bottom of the page, the very bottom of the site, you will see links for Amazon US, UK, Newegg, ThinkGeek, Best Buy, Mint.com, and Audible.com, which you guys know I love. And a Chrome extension. Those links there, if you click one of those links before you shop at one of those sites, it'll tag your shopping session and give Jupiter Broadcasting a small percentage. And if you use that Chrome extension, it auto-tags your shopping session whenever you're there, so you don't even have to think about it. And that's pretty much it. It's as simple as that. Click before you shop, and you support Jupiter Broadcasting when you get yourself something, without really even having to think about it. How great is that? So thank you, everyone who does that. We do very much appreciate it. All right, I believe it is time for the SciByte News Bite.
That is right.
What is our first story in the News Bite, Heather?
We're coming up on a transit of Venus. It's when Venus will pass between the Earth and the Sun. It's actually, so that requires one of the inner planets, Mercury or Venus. That's just two. But Venus is among the rarest of planetary alignments. It happens at really weird occurrences. It's like 121 years, then another 8 years, then another 105 years. So the last one happened about 8 years ago. I recall that one. I got to actually witness that one. It'll only happen, so it only happens about once every 4 times, every 243 years or so. And it will only happen in early December or early June. just because of the way the planets line up.
Okay.
And only 6 of these have actually occurred since the invention of the telescope.
Wow. Yeah, I guess, right? I mean,
yeah,
that makes sense.
1631, 1639.
You're talking 243 years, right?
Yeah.
So, yeah.
Yeah. The last one was in 2004. I remember that one. But your location on the Earth is going to depend what you see and when you see it. It's at the max, it'll last about 6.5 hours from specific points. Northwestern America, Hawaii, Western Pacific, Northern Asia, Japan, goes on and on. The sun will... So now for some people, the sun will set while the transit is still in progress. That'll happen for most of North America, the Caribbean, and Northwest South America. So it'll be in progress while the sun sets, and then it'll also be in progress while the sun rises for Central Asia, the Middle East, Europe, and Eastern Africa.
Awesome.
Yep. People in certain parts of the country the world are kind of doomed. They won't get to see it.
Yeah, I'm looking at the map you provided in the show notes, and there's some pretty big gaps. Like especially, so if you don't follow under the red line, you don't get to see it. Is that what I'm interpreting this map as?
Yeah, the dark area, you don't get to see it. It'll say
anywhere in the dark area,
visible.
right? Transit not visible. So yeah, like big parts of South America are kind of getting left out in the dust there. And it looks like half of Australia, really. Well, no, I take that back.
Nope.
So that's good.
So you can see, it'll tell you the whole transit is visible, or transit will stop during sunrise or during sunset.
Yeah. Huh. That's pretty neat.
And Halley, the guy who did Halley's Comet, he was the first person to realize that the Venus transit could actually be used to measure the sun's distance, establish a scale of the solar system. And the timing of the transit to the surface of the Earth gave a certain degree of you can't get a precise measurement from the Earth's surface because due to atmospheric conditions and diffraction, so the timing can only reach a certain degree of accuracy. And so the last two back in the 1700s were able to give good values for how the sun's distance were. So there's this one happening this year. The next one will be on December 11th of 2117.
2117. Well, let's see.
Yep.
That doesn't really matter because I believe everything ends on December 21st, 2012, Heather. So
Okay.
null and void. Sorry about that.
Okay.
Sorry, that wasn't very sciencey of me.
It's okay.
All right.
I said it was, this happens not so often. Mercury, on the other hand, it'll go through 13 or 14 every century. And this one, will take a century for the next one to occur.
Okay.
So Mercury happens quite a bit more often.
So take advantage of what we can.
Yeah. Mercury zips around pretty quick so we can see it. But yeah, it's one of those things that if you have a local observatory or local astronomy group, they'll probably do something for it. Since it's transiting the sun, never, ever, ever look at it with your eyeball or binoculars or anything like that.
Right.
You have to have the proper equipment should you wish to actually, see the whole thing.
Right.
Otherwise, everything will transit and it'll be very dark. The sun will be completely blacked out and will not be a lunar eclipse.
No, that's sad. Don't do that, people. Follow the rules. Follow the rules when it comes to the sun. Don't screw with the sun.
No.
Any other thoughts on that story?
No, it's just one of those interesting things that doesn't happen very often. Kind of give people the heads up. I'll probably mention it right before it happens, too.
Yeah, there you go. Well, all right. So I heard a little rumor that in Norway, the sky was falling. What's going on over there?
So Norwegian family arrives at their holiday cabin. It's been the first time all winter they're able to go, and there's a hole in the roof. And there's a rock. A meteorite had fallen through their roof sometime during winter.
You never really think. I mean, you might think like a tree is gonna fall on your roof. You might think something's gonna. But a meteorite, that doesn't. No, I don't really think. I don't worry about that too often.
Yeah, I don't really think that's a normal thing under renter's insurance or anything like that. Meteorites through the roof. But
No, I don't think so.
No. So they don't precisely know when it was, but there is a pretty good idea of when it happened. There was a wave of meteor sightings over Norway on the March 1st. So they're pretty sure
that's wave of sightings.
Yeah, there was a whole bunch of sightings. There was a big, meteor shower. So they're pretty sure that that's probably when it happened.
That must have been it. Yeah, and they just didn't notice.
Yeah, well, nobody was there to notice.
Oh, yeah. Well, there you go.
Yeah, it's not available to get there. My college had an observatory up in the mountains, and you couldn't get to it all winter. So there was you rode across the highway so that you could peer at it with binoculars or a telescope between these two mountaintops.
Then you
can kind of peer through it. You'd be like, is it okay? Oh, right. And it's one of these days, my professor's one of these days I'm going to be afraid that one of the roof pieces is blown away, and I can't do anything about it. This was a 1.3 rock. It split into two pieces.
But do they get to keep it? Because it's like space rock. It's theirs.
Yeah, I mean, generally, I'm not sure how the rules of the legality of Norway are, but generally you keep it and you sell it. Sometimes people will loan it out to a museum, some sort of local museum, sort of permanently loan it out.
I'd want to hold on to it forever because I can fix a roof, but I can put that on my shelf and be like, you see that? Yeah, 30 years ago that came flying through my roof and nearly killed the whole family. But luckily I had my good old catcher's mitt, and you can just and then somebody they could even take the rock and test it, and it'd be a true space rock, and you'd be like, yeah, so the whole story's true.
Yep, and this wasn't just random space rock either. This was one that was a whole bunch of different ones, kind of a whole bunch of smaller fragments of minerals kind of globbed together.
Kind of like a space rock mutt.
Yeah. So it was kind of weird because those are in the more, they're not the average to fall from the sky. Now, it's kind of funny because, you see these stories and you're like, oh no, meteorite's going to crash through my roof or crash into my car. But they rarely fall in populated areas. According to some news from Norway, only 14 have been found in the Scandinavian country since 1848.
Oh.
So not many, according to them, very few fall in the entire country since, the mid-1800s.
That's more reason I'd never get rid of it.
Yeah. You're like,
Because you never know. I mean, you sell it to somebody, for all you know, they're going to try to crush it up and smoke it or sniff it or something. I mean, you never know. You give people space rock, you never know what they're going to do with it. But me?
And taxes.
Yeah, okay. Sure, I could see that. But for me, I just hold on to my space rock.
Yeah, I just hold on to it.
Like Cheese Bacon say in the chat, maybe I'd loan it out to people.
Yeah.
People could borrow my pet space rock.
Your pet. It's even better than a pet rock. This is 1,000 times more awesome.
Exactly.
It's a pet space rock.
Exactly. All right. Now, towards the beginning of this here program, Heather, I believe I was promised lasers.
You were.
Can you deliver?
Yes.
Okay.
New research has found that brief bursts of intense laser light can actually redirect lightning.
Whoa, wow, whoa.
Yeah.
Really?
This was an awesome story when I read it. Some researchers in France have successfully directed laboratory-generated lightning to strike the same place, not just twice, but over and over and over again using a laser.
So you're telling me they can fight lightning with freaking lasers?
Yes. Now, I don't know if they'll mount them on sharks, but you can fight it with, direct it to a specific point. It's one quadrillionth of a second flash of laser. So it creates a sort of a virtual lightning rod.
Yeah.
So a column of ionized gas that kind of works as a lightning rod, except it can go over 164 feet. So it's an incredibly long one. So you kind of point this up, and even lightning rods, it's sort of a preferred, place for it to go, but it doesn't necessarily have to go there.
Mm-hmm.
There are definitely things coming up saying, I want to be a lightning spot. I want to be a lightning spot. It doesn't necessarily have to go where you want it to go.
What I wonder about this is, does it, according to this animation that I'm looking at of it right now, it appears that it is like an on-demand laser. It fires as it detects lightning. That doesn't seem possible.
I believe the animated GIF that was there is just sort of how lightning works in general.
But it's got lasers. Oh,
Well,
no, I see. Okay, I see.
that's just sort of the general.
Gotcha.
Talked about it back.
Those weren't lasers. Those were like ion somethings or others.
Yeah. Negative charge is coming down from the clouds, and then the positive charge from the Earth is kind of reaching up.
The clouds are like this negative dimension, right?
Yeah, negative dimension, and the Earth is a positive dimension, and when they collide, it's
unless you got lasers.
It still collides, but the lasers can direct them to, go where you want them to go.
This is really, this could be really great.
Yeah. And, they've tried to add longer or pointed, when they were doing this laboratory generated, they did, round, pointed, they were trying all sorts of different configurations of, the laboratory lightning would really want to go to a specific place, and it really should. But the laser kind of redirected it to wherever they want it to go.
I would think that there would be a challenge in getting, you would almost have to have some sort of, I guess, like a real lightning rod. You'd have to have it always sort of present. You'd have to have the laser always working. You couldn't just have it on demand, because I would think that the computer wouldn't be able to respond fast enough, but I don't know.
Yeah, well, that's...
In a controlled environment, I could see how they can make it work fairly easily, but in the real-world application, it seems like that could be a bit of a challenge.
Yeah, at a quadrillionth of a second, it doesn't take long, but it's not like you could look for the flash. The flash means the lightning's already happened.
Right. You'd have to be able to observe, the atmospheric conditions and...
Yeah, but maybe it's that when a big lightning storm is going through, I don't know, maybe this goes off every once in a while. It's not really the practicality of it. How often do you have to do it? How can you read that it's going to happen? Can you, there are, those positive leaders that you saw in the animated GIF coming up, the red ones.
Mm-hmm.
Could you detect that there was some sort of electrical charge, a leader? I've actually heard, a crackle of the air, where a lightning could have struck.
Yeah.
Where a lightning bolt could have struck. And so can you detect that is near? And then if you detect that is near or in a certain location, say you have a building and you detect that is that crackle, that the positive leaders are kind of coming up. So maybe you have this laser, 20 feet away from the building or so. And then once you start detecting those charges, then you start flashing off the laser.
Yeah. Yeah. That's could be, there could be a lot of interesting mobile applications for it, for military installations and all kinds of really fascinating things, and even town safety at some point in the future. That's all way off, but
yeah.
Made me think, Heather. I never would have thought of something like that. Any other thoughts on this story?
No, like you were saying, it's military or any remote location that would have a generator that might, if it's the only big metal object in a while in a good area, then maybe it's. Maybe you could use it to deter the lightning from attacking that, or, fields, sports fields or something.
Oh yeah, wow. Well, it's just another example of something that lasers can do. Lasers will never cease to amaze me.
Exactly.
Oh, well, that pleasant tone is here to remind us all about the Jupiter Signal, which comes out this week, and that's Jupiter Broadcasting's monthly newsletter, where we put behind-the-scenes info about shows, follow-up, trivia stuff, links to things. It's just a good community service, and we'll put a little spot in the show notes for this episode, but you can also just go to bit.ly/Jupiter Signal, and you get that monthly newsletter totally free, and we're not even able to spam you. Like if I went to my wife Angela, who really works her butt off on the Jupiter Signal, and I said, Angela, I would like to spam everybody on the mailing list, I couldn't do it, because what happens is MailChimp actually drives to my house and beats the crap out of me. So it's totally safe from spamming, because otherwise they get beat up by monkeys. And,
after you got beat up by Angela for wanting to spam.
Right. And then also all the people we spammed who probably would figure out where I'm at and come beat me up also. It'd be a bad week if I spammed people. Yeah. So check out the Jupiter Signal. It's coming out this week. If you're hearing this on Friday, it's probably already out, but I'll tell you guys a secret. If you sign up, there is a link, I believe, somewhere in the newsletter where you can actually go back and look at the past ones. And they're all awesome. So go check it out, bit.ly/JupiterSignal, or just look for the sign-up spot in these very show notes, because that's where they will exist. And that makes it super easy. What do you say, Heather? Should we move on to the 2-Byte news? All right, well, let me just grab my books here so that way I can refer to these as we do the show. You know, I prefer everything in paper, and oh boy, these things are heavy. All right, Heather, what's our first 2-Byte news story?
Encyclopedia Britannica. This year will be the last year it is in print.
What? But I just got all these books.
Yep, and this year's will be the last year that they publish new ones.
Ah, I heard about this. It's a sign of the times, right?
Yeah, I mean, it's been in print since 1768. So it's been in
that.
244 years. They're gonna focus on their online encyclopedia. So
yeah, I read somewhere. I think I read a stat somewhere that the Encyclopedia print edition was representing only 1% of their sales. Did you see that anywhere?
Yeah, I think so. I mean, the top year for the printed was 1990. And it's, 120,000 sets were sold. By 1996, only 40,000.
There is something, though, about having, like, quote-unquote, a great representation of human knowledge in a set of physical books.
Yeah. Well, it's like, I remember going to the library growing up, and, it's like, we actually had a index card reference thing. So, like, going up to the little drawer and rifling through the index cards.
The Dewey Decimal System.
Yep, the Dewey Decimal, and be like, okay, this is the over here is the Encyclopedia Britannica I want. And then going over and lifting up the book. And it was really heavy, and like plopping it down on the table and be like, okay, where in this book was the information I want? I
remember, this is a funny way to think about this. But, when you think of like technologies that are game changers, like, the iPhone came out and now everything is a touchscreen smartphone, right?
Yeah.
I remember when Encarta and just the CD-ROM came out in general.
Oh, yeah.
And I remember, like, at school, like, they'd hand out these CD-ROMs inside these trays, and you'd have to go load them up in the machine. And just as a kid, I think I picked up on the fact, like, this is a big change. And to me, it was way cool because I had Encarta at home. I could have, I could have video and audio in it. It's a big swing, but I guess part of me is kind of sad to see that there's not something in print, though.
Yeah, it's got its good and its bad. It's a lot faster to find the information you want, but it's a lot faster to find the information you want. One, it is not in print. If, EMP and there's no knowledge of the world, it only goes up until, 2012 when the last Encyclopedia Britannica was printed.
That's not so bad. But, it's an old joke, but... everybody always says the compatibility and battery life on my books beat the e-readers any day of the week.
Yeah. And you really remember like going and looking for the right book and, having, I've been in the encyclopedias where there's like index books. You have to go to the index book and look up the keywords to find out which book you need to look into. It's like, look in book 4, chapter 7.
Right.
And so then you go to book 4, chapter 7. To start looking for the information you want.
Well, you know what it kind of reminds me of too, and this was a big shift, is I joined the IT workforce right before web search engines existed. And we had libraries of technical manuals, and like we would go every couple of months, a couple of the guys from the office would go down to the bookstore and figure out what books we needed to buy so we could look up things and stay current. And we had internal knowledge bases. And when Google came around and forums came around and Wikipedia came around, all of that went away. It all just died. And that's kind of what's happening now with Encyclopedia Britannica.
Yeah. So, you can't really blame them. That's a big book. It costs quite a bit to make that. And their sales aren't doing that well.
It's like $1,300, right? Or $1,400 to buy it as a consumer. So who's gonna drop change on that when you could just web search?
Yeah, a lot of schools are the ones who buy them every once in a while, and there's a lot of budget cuts here and there, and why not get it digitally when it is so much cheaper.
Yeah, and since lawyers' offices just started stocking their shelves with fake show books, the sales probably really dropped down.
Cardboard cutout books.
Yeah, exactly. Like something you'd see at IKEA.
They're like, somebody goes to pull off a book off the shelf, like, huh? They like just hand over their e-reader. Why are you worrying about that?
They published their first CD-ROM in 1989.
Yep.
And their encyclopedia went online in 1994. I mean, that is... Yeah. A CD-ROM in 89 is ahead of the curve, and really the entire encyclopedia online in 94 also pretty much staying up with the times. I'm actually kind of, with those numbers, I'm kind of surprised they haven't killed it already.
They actually started like exploring the idea in the 70s.
Wow. I really respect these guys for kind of just being willing to just stay up to date with it.
I mean, they're like, this looks interesting. Maybe we should keep an eye on it. I mean, they announced that. I think they made the entire contents of the website available for free for 1 week. I'm pretty sure that is just ended. I didn't catch the story in time to warn people last week.
That's okay.
It's okay.
You know why? You know why you didn't catch it? Because you were probably too busy watching this guy skydive from space.
Oh my goodness.
This is a great story. I only saw the headlines and I saw a still of it, so I actually don't know all the details. So fill me in. What's going on here?
Okay, so it's not technically space. It's one of those things where we have talked about it many times. Space is blurry, but it was definitely near space. On the 15th of March, Felix Baumgartner jumped out of a little capsule, Red Bull Stratus project. Jumped out at 71,580 feet, landed 8 minutes and 8 seconds later.
Wow. So wait, he jumped out at 71,000 feet?
About a little over 13 and a half miles.
This guy's got some serious cojones. I mean, I would be honestly worried about just getting some sort of critical velocity that I just ripped my parachute or something like that.
You don't deploy your parachute at critical velocity.
Okay.
There are actually various types of parachutes also, but I mean, he got up to 364 miles an hour. It was in free fall for almost 4 minutes.
Wow, how exhilarating.
Yeah, it's kind of creepy. The type of balloon he's launching, I've actually dealt with those before. And they don't look very poofy. You fill them up and then they rise, and the higher they go, you get less external pressure, so it goes larger and larger and larger.
Yeah, right.
And so they had this special capsule built, so you can kind of sit down and, I guess, what
watch
I would
the ride?
do is like have my finger on the red button, like never mind.
It looks like an escape pod from Star Trek, and it's got this big almost aquarium-like window where you can see him sitting inside of this seat, where you would say he's sitting at controls, but I don't think there's actually any controls or anything like that for him. He's just going up, and then he's going to jump out, right?
There's probably some instrumentation. I mean, you could have an altimeter to tell you, the height or temperature or pressure. There's probably a minimal amount of things that he's gonna.
In fact, I was just looking at the video, and they actually, he has exactly a control panel that has some dials on it that looks like it's exactly that.
Yeah, probably something to unlock the door, because it's probably a very carefully locked door.
Yeah, he gets up to the top and he hits a button, and that door just slides right open, and then he's got like this one little step that he can step on outside the vehicle as he's orbiting above the Earth. Yeah.
So a creepy thing is that there is this zone. Once you launch, from that to a specific height, I don't recall the height, but it's like a red zone. You can jump out, but there's no time for your parachute to deploy.
So he has like this area that he has to get through, essentially?
Yeah, until you reach a certain height, better hope you don't have to go outside.
Wow.
Or that something doesn't fail.
And it's interesting, too, that Red Bull is throwing in a bunch of money on this. I wonder what their angle is on all this, other than just maybe publicity.
Oh, it's obviously publicity. I think they had some legal battle. Otherwise, this would have happened a little while ago. Some legal battle about somebody else said, no, you stole our idea. We wanted to do this.
Oh. You know what? There's plenty of Earth for people to fly up to, on top of, and jump down onto. People don't need to fight over it.
No. And this wasn't actually the highest he's going to go.
Right. This is more of like a proof of concept test, right?
Yeah. This is a little over halfway to what he wants to go to.
Ooh.
Yeah. He's like record-breaking 120,000 feet. At that, he'll be in free fall for about 5 minutes. He will actually achieve Mach 1.
A human being free fall will hit Mach 1.
He will break the speed of sound. He will break the sound barrier. Now, I've heard some people going, no, you can't really do that. You reach terminal velocity before you get there. But what it is obviously the atmosphere is a lot thinner there. And so there's a transition area, and through the thinner atmosphere and thicker atmosphere, you can actually sort of cheat. In the thinner atmosphere, you have a specific terminal velocity. It's the fastest you can fall. And you can actually break the speed of sound there, so you can reach Mach 1. And when he reaches his final height, the descent from stepping off and being a completely crazy person to landing, about 15 to 20 minutes.
Would you ever try something like this?
No, we talked about this at work about a week ago. And people were like, oh my gosh, yeah, can you imagine like the moment when you're crazy, like you step out or you do this or, you have to get past that red zone. And I was like, you know what? You know when I thought I'd be crazy? When I said yes. When I said this sounds like a great idea.
Yeah, the red zone makes me the most nervous because, like, what if there's a fire or the balloon starts just not doing so well?
No, something is not connected right. And the balloon, hits a gust of wind and it keeps going and some chink in it falls, and that's not good.
Now, according to Josie Wales in the chat room, the Project Excelsior had somebody jump from 102,000 feet.
Yeah, there have been other people to do this.
Back in 1959, it looks like.
Yeah, so there are definitely other people who have jumped from very high heights. There's only a handful of people. Technically, if he actually reaches the highest, it will be the highest, and he will be the only person to break the sound barrier with just your body.
Did you know that the original opening to Star Trek Generations was Captain Kirk parachuting from space?
Yes, I did.
So I actually, when I heard it in there, I thought, oh, that's just crazy, way off sci-fi stuff. I didn't realize it was stuff that people actually do.
Yeah, I kind of thought about that too, and I'm like, I don't really know about that, but yeah, obviously you don't deploy your parachute until you reach a certain altitude.
Right.
And that's one thing where you have to rely on an altimeter. You have that on your wrist, and it tells you how high you are, because height can be very deceiving when you're falling from that high.
Yeah.
He was talking about, he was looking down at the ground. He's like, oh, it's time to pull my parachute. And he looked at his altimeter just real quick. And he's like, I'm still at 50,000 feet.
Yeah,
yep,
well, I mean,
it's time to pull my parachute.
It's not like you have like really great points of reference because everything from that high kind of looks the same, and you can't look over and gauge at something and how high it is because you're about as high as anything gets.
Yeah. So
which is how the state of mind I would have to be in order to do something like that, about as high as someone can ever get, because there's no way I would ever do that.
Yeah. You have those pilot chutes, or get to insert. You have terminal velocity, so you only go so fast. And once you get through a certain, layer of the atmosphere, you can only go so fast, and you can have a little parachute that can slow you down just slightly and then pull out your big chute.
The chat room thinks that I should do this, so maybe I could combine something with this and like the Lego shuttle for promotion for SciByte.
How about we instead send a couple of little Lego people that we draw as ourselves with a Jupiter, sign behind us?
Okay.
And we put that on the balloon.
Just our picture.
Little Lego us.
Yeah. Okay. All right.
You can have like Lass over here, and it can be like you and Brian, and then like Tech Snap, and it'll be you and Alan, and
sure.
Stoked, and it'll be like, I don't know, various peoples. SciByte will be us.
Yeah,
the
okay.
big Twitter sign in the background.
There might be something we can work with there. Yeah. Well, all right. I like that.
Lego instead of us.
Any other thoughts on that story?
One thing I did find interesting is back in the 70s, Kissinger did something like this, where he launched pretty high up, and they actually had him as a technical support on this project. he launched, and when he was coming down, his little parachute, his rogue chute, it didn't deploy right, and it actually wrapped around his neck.
No way.
Passed out. And for some of these, you'll have automatic deployment at specific altitude.
Okay.
And so he got through a specific altitude, and his chute automatically deployed. And they were able to go and collect him and his chute.
Was he okay? He was okay?
Yeah, well, they have him, talking with him on this one. Yeah. And he's not zombie Kissinger.
Oh, he looks kind of like a zombie, though. He's got some zombiness to him.
He's just an old man. Leave the old man alone. He jumped from a really high height.
All right, you're right. Hey, you know what? I got this computer right here in the studio, and I only use it for SciByte, and it's got this flashing red light on it. Let me... Oh, it appears we have some updates.
We do.
What are they?
Neutrinos. They travel round and round and round again. So, fresh measurements of the tests... a team working independently, neutrinos do not travel faster than the speed of light.
So is this sort of the definitive, we can put this to bed, the neutrinos faster than light story was based on mistakes and loose cables and...
Not necessarily a mistake, but yeah, an artifact in the measurements, which is essentially a loose cable.
Come on, Heather, come on.
Okay, you know what? You something really funky happens, you tend to blame the instrumentation. But when you're in somewhere like CERN, I mean, this is, big physics.
Yeah.
Giant particle accelerator.
Huge machine.
There are some things you assume, like cables are plugged in properly.
Right.
So there are some things that you can sort of like check and kind of go through all the instrumentation and all the measurements and check on all this stuff. But this is an independent study, and after everything's been fixed, and they say no. Okay. Now, of course, never say never. More checking of all the instrumentation and some more independent tests should probably be done before it's put to bed, at least for now.
Now, why do you say that if we've had a couple of different people verify it now, a couple of different groups?
I think this is the first independent group. I think the original group found it. The last time I was looking at it, there was a loose cable, and there were one or two other things that were kind of messing with the timing of it all.
Okay.
So once you get all the equipment checked out, and in that big of a facility, it might take a little bit of time to make sure that all the equipment is perfectly happy.
Yeah, it's big. It's big.
I mean, there's two different locations here. There's two different locations. There are a whole bunch of timing instruments. There are satellites.
Right. There's
so many different things going on in a couple of different sites and locations that you really want to make sure everything is happy and that a couple of different groups independently verify something.
Yeah.
I mean, you want that to happen to prove it. You also want that to happen to disprove something.
Yeah.
The amount of check work and measurements and repeated conclusive evidence that you need to say, yes, this is real, you really also need it to say this is not real. So Skeptical Pants is still on.
Yeah.
But, I won't foo-foo it completely.
Yeah, okay.
Until there's been a couple of independent, groups verify this and make sure that all the instrumentation and equipment still checks out. Maybe do this now and repeat it in a year or something. So
I think I'm a little bummed by it just because I love the big implications if it was possible. If neutrinos were faster than light, that is a really big deal that rewrites a lot of things that we understand. And I think that would be an amazing thing to happen. But
just why do you want to break my science?
No, actually, I'm also happy that it confirms the science. So yeah. Really,
it would have been something really interesting because it seems like, especially in astronomy, about the time we think we understand how things go.
Yeah, exactly.
We're like, oh, never mind.
Exactly.
Take that back.
Yeah. Speaking of astronomy, it's sort of like when you have a loud neighbor that you can't do anything about. What do you do when the sun is your neighbor and it's noisy? We have a story about that, don't we?
We do.
In fact, I even have some little sounds. So you let me know when you want me to play it.
Okay. So last SciByte we talked about some big solar flares that were, a couple of big ones that all came from a specific sunspot group.
Right.
Well, unleashed another one on March the 13th. It wasn't headed towards Earth. But also what has happened is there's something called sonification. It's when you take scientific data and you turn it into various sounds. In this specific case, there was a student or an intern or a scientist that had some background in music and instrumentation and stuff. They actually had something similar. The probe that landed on Europa, the gas.
Oh yeah.
It landed on the surface of the moon, has an atmosphere.
Mm-hmm.
And not Europa. Oh goodness. Cassini-Huygens, it landed, and they actually turned some of that data into sounds. So, every rotation was a click. Every time it took a picture, it was a ding of this noise, and every time it took a piece of data, it was like all these different things, and you could listen to it, and you could hear how fast it was spinning and how it slowed down and how many pictures were being taken.
Yeah,
and you can, by hearing it, you can hear a lot of sounds. You can get a lot of information. You can hear repetitions. And in this case, he made a sonification of the recent solar storm activity from 2 different spacecrafts. He turned it into sound. So you can go ahead and play an instant of it.
Check it out here. This is really, we have a couple different spots we'll play.
Yeah.
This one is sort of a mean, bassy one.
Yeah.
Kind of sounds like a monster.
Yeah. Fast ion plasma hitting the instrumentation.
Yeah, this one's really great because as it gets really excited, you see a lot of particles coming off the sun.
Yeah.
And this next one, the sun right there.
Yeah.
And as it gets crazier, there's just more and more particles. Oh,
yeah.
That's really cool.
You can see it, you can hear it, and you can zip through days worth of information, compressed down to an instant, to a few seconds, and it's funny because the human brain really picks up, specific repetitions and things
patterns. We're pattern recognition machines, Heather.
Yes. And so you can listen to it, and you can listen to days worth of data and say, I recognize a pattern here, I recognize a pattern there. And it's easier to pick up and much faster to pick up. And so they've been trying to do this sonifications data for a couple of these different instrumentations, and when they can, because you can pick up on those patterns. And you can, instead of compressing all the data down from a couple of days and you're trying to average out the numbers and see how they chart out, you can just crunch it down into all the data in different sounds and listen, have it be 5 minutes of sound and listen for the patterns. Be like, hey, I hear something here and I hear something there. Let's check those out.
It's a great way for the human brain to work with a ton of data in a way that is like our mind is really, it's like if you had an accelerated encoder for information, it just processes it. Like even just watching that as a dumb monkey seeing it for the first time, I was recognizing patterns.
Yeah.
So it's definitely, we're wired that way.
Yeah.
Well, that's a good one. Any other thoughts on that story?
No, it's just one of those interesting ones that was really good for an audio show because you can hear all the different sounds of things going on. You're like, whoa.
And if you really want to be tripped out by it, you can go to the links Heather has in the show notes and watch the whole thing. It is really fascinating, especially those plumes. It's just,
you can see as things, mass ejections kind of occur off the sun, or when they do it, you can kind of hear what's going on, sort of.
Yeah. Yep. All right, Heather, we'll put down your hearing aid and step over here into the time machine because it's time to go. Come on, get in here. Here we go. We're going back in time. We do this every week on SciByte. We look back in this week in science, and the first destination this week is 153 years ago, March 26, 1859.
Yes. This one was one I could not pass up. Vulcan discovered? Question mark?
Like Mr. Spock's Vulcan? Really?
Yeah, yeah.
I knew it. I knew it's true. Star Trek was true. I knew it all along. I was telling everybody. They'd just laugh at me.
Yep. So 1859, a French medical doctor, amateur astronomer, he reported seeing a new planet in orbit around the sun, like inside of the orbit of Mercury. He called it Vulcan. He'd seen round black spot cross across the sun. It took 4.5 hours to cross. He sent this information and all his calculations of the movements on to the most famous French astronomer there was. He kind of noticed that Mercury had deviated its orbit just a little. So he thought, hey, gravitational pull from Vulcan would fit nicely into that.
Aha.
Unfortunately, when it should have been seen again, it wasn't. So it's now believed to actually have been just some sort of rogue asteroid.
Yeah, okay.
Making a one-time pass by the clock.
Or a giant spaceship.
Yep. Or either that or this is the non-prime universe and it was destroyed. Cue Brian crying out in anguish.
I actually thought you were about to go somewhere serious and just let me throw that in there, but you just took it further.
Nope. Yep,
all right, well, sounds like they were having a real party 153 years ago.
Yep.
So where's our next destination take us? I believe it's 42 years ago, March 25th, 1970.
Yep. The prototype British-built airplane, the Concorde, made its first supersonic flight.
Oh, wow.
Yep. The 002. Just a few months earlier, the French prototype had broken the sound barrier. So the British-built one is one we're talking about. So, within a few months of each other, they were able to combine the number of supersonic flights, by 100 by a year later. So the two of them were able to, rack up 100 supersonic flights in a year.
Now I believe they're all grounded, right?
Yeah, they grounded them all and stopped flying a few years back. I don't recall the exact year.
That's a bummer. But I guess there's some dangers and some safety stuff or something.
Yeah. It was getting a little old.
All right, Heather, let me retune the SciByte computer so that way we can look up into the sky this week. What's coming up this week in the sky?
This week on the 22nd, we have new moon. So it'll be completely dark.
New moon.
New moon.
Okay.
On Friday, March the 23rd, we're going to start keeping an eye out in the west for Venus and Jupiter still, and a thin crescent moon. Jupiter was higher for the longest time, but now it's a little bit lower than Venus. But it's still easy to tell which one's which because Venus is much brighter, but Jupiter's pretty bright too. And starting just a few days later, on I believe it's Sunday the 26th, Saturn will start rising about mid-evening, just to the left of Spica. Spica is a very bright star. I've always kind of thought it kind of shifty in color, very, very twinkly.
A shifty character, huh?
Yeah, but Saturn will be to the left of it. So be kind of hard. It's much dimmer than Spica, but you'll be able to tell, like, bright star, dimmer, quote-unquote star. You're like, see that? The bright one's a star, the dim one's a planet.
Oh, okay. That's always a good way to go.
Be able to show off all your knowledge.
Your science knowledge. You can be like, that's the great thing about SciByte, right? So you'd be like,
yep.
oh yeah, that's totally, et cetera, et cetera.
That's easy.
Yeah. I told you, like, last week I kind of saw on the web stats that I think people come back and refer to this throughout the week, which I think is adorable.
Yeah.
Because I totally do that too.
Yeah. Why not?
All right. Well, cool. So there you have it. All of that stuff is in the show notes, and as well as links to even more stuff we didn't even get a chance to talk about.
Yeah.
There's a lot of science that happens on a weekly basis.
There is.
And you do actually a pretty good job of capturing some of the best of it right here. So there you have it.
I definitely try.
All right, Heather. Well, good show.
All right. Good show.
We is the video version next week?
It is next week.
Oh my gosh. It feels like we just did that. All right. So SciByte is live over at jblive.tv on Tuesdays at 7:30 p.m. Pacific. And next week would be a great week to join us because we'll be doing it in video form, which means you get to see our faces. And of course, even when we're not doing it in video, I still encourage you to show up because honestly, then you're the star of the show because we usually have our chat room up when we're not showing visuals. So, all right, Heather. Well, thanks so much for a great show.
Thank you.
All right, everyone. We'll be sure to tune back into SciByte right here next week. It usually comes out Wednesday mornings over at jupiterbroadcasting.com, and you can get it in just about any format you want, including audio versions, video versions with visuals, and you'll also find the RSS feeds where you can get it weekly. But I think that just wraps up everything we've got for you this week. We'll see you right back here next week.